Solving rational equations. These are equations containing rational expressions. When solving rational equations, it is important to identify the domain of the variable, which means the values that are possible for the variable, and we exclude all values of the variable that result in division by zero, since division by zero is undefined. Number two, for example, solve x plus 5 divided by x minus 7 equals the ratio x minus 3 divided by x plus 7. Step one, determine the domain of the variable in the rational equation. For what values of x will either denominator be equal to 0? So let's look at the denominator x minus 7, and it will equal 0, means solve for x. So if we solve for x, we get x equals 7. That's not the solution. That means we have to exclude 7 from being a possible solution, because if you were to plug in 7, the first fraction denominator would be 0, and division by 0 is undefined. The expression would be undefined. Similarly, the right fraction denominator will be 0 if you were to substitute negative 7. That would give division by 0, and the expression is undefined. So positive 7, negative 7 cannot be solutions. So the domain, or the set of all possible solutions, is all real numbers except positive or negative 7. So we can express the domain as, in different ways, all real numbers except, looks like a subtraction sign, positive 7 or negative 7. We can also express it this way using what is called interval notation. The domain is any real number in the interval negative infinity to negative 7, or could be any real number between negative 7 and positive 7. Parentheses exclude the values negative 7, positive 7, or, and the U symbol means or, which also means union, or it's possible the solution could be greater than 7. In set notation, we could say the domain is the set of all real numbers x such that x is not equal to positive 7 or negative 7. So again, domain means the set of all possible solutions from the set of real numbers, excluding any denominator restrictions. Step two, determine the least common denominator of all denominators, which is the product of the denominators, which are prime, which means x minus 7 cannot be factored, times the prime polynomial x plus 7, product of prime factors of the denominators. So that is the LCD. Step three, we're going to multiply every term in the equation by this LCD. And let's do that right here. So we're going to go x minus 7 times x plus 7 multiplies the left-hand side, which is x plus 5, divided by x minus 7, equals right-hand side, x minus 7 times x plus 7 times x minus 3 in parentheses, divided by x plus 7. So now we can divide and cancel. On the left side, x minus 7 divided by x minus 7 is 1. X plus 7 divided by x plus 7 is 1. And so now let's write it over again. We have x plus 7 multiplied by x plus 5 is equal to x minus 7 times x minus 3. So let's multiply out. Maybe we would use the FOIL method, product of the first terms, product of the outer terms, product of the inner terms, and product of the last terms. So x times x, x squared, x times 5, 5x, 7 times x, and 7 times 5, 35, is equal to x squared. Outer product is minus 3x, inner product minus 7x, and then plus 21. So simplifying, we have x squared plus 12x plus 35 is equal to x squared minus 10x plus 21. Now, x squared is a term on both sides of the equation, so we can subtract it away. Call it a pair of balancing terms on both sides. Let's add 10x to both sides. So now all the x terms are on the left side. Thus, we need the constants on the right side. So we'll subtract 35 minus 35. Do the canceling. So we have 22x is equal to a negative 9 and 5, 14. So divided by 22 on both sides, we have x equals negative 14 divided by 22. We can divide by 2, so we get negative 7 divided by 11. Number 3, solve the rational equation. First, part A, determine the domain, which is generally all real numbers possible except for denominator restrictions. Now we have to restrict 0 from being a solution, because if we substituted 0, we would have two expressions with division by 0, which is undefined. So x cannot equal 0. 0 cannot be a solution. So again, that's called a restriction on the variable or an excluded value. The domain is all real numbers. Potentially, the solution can be any real number except, so the minus, what looks like a minus means except 0. Or we can write it this way with what is called interval notation. X could be, let's use it a little more technical symbols here. Potentially, x could be an element or any real number in the union of the two subsets, negative infinity, comma 0, union, which means or. X could be any real number from the subset 0 to infinity. Some positive real number, potentially. Step B. Let's find the least common multiple of all the denominators. So if we look at the 12, the 2, and the 3, since 2 and 3 are factors of 12, the LCD will include 12. X is necessary to include, and you use the greatest exponent, which is 2. So use the greatest exponent on x in the least common denominator. Multiply both sides of the equation by this LCD. What's the resulting equation? So let's do that here. We're going to go 12x squared times the first term plus 12x squared times 1/2 equals 12x squared times 1/3, or 1 divided by 3x, plus 12x squared times 2 divided by x squared. So the next step is to divide and cancel. So we'll divide 12 divided by 12 is 1. 2 divides 12 6 times. 3 divides 12 4 times. And a single pair of x's will cancel out. So that'll eliminate x in the denominator. And instead of having 2 x's, we'll have just 1x in the numerator. And then x squared will divide x squared, give you 1. So we have x to the third, a cubic, plus 6x squared equals 4x plus 12 times 2 is 24. So here's a cubic equation, a polynomial equation with 4 terms. So let's set it to 0. We have x cubed plus 6x squared. Now these two terms have a common factor of x squared. And then if we minus 4x from both sides and minus 24 from both sides, we get z equal to 0. Now we have to be careful with minus in the middle, because when we insert the parentheses or grouping symbols to use the grouping method, minus in front of a parenthesis distributes, so the minus in front of 24 becomes plus. And good thing is we have a common factor of 4 there that we can factor out. So let's factor out x squared, the greatest common factor, times x plus 6. Factor out 4 times x plus 6. And thus, we have x plus 6 as a common binomial factor that we can factor out. So x plus 6 multiplies x squared minus 4, and that equals 0. X squared minus 4 is the difference of two squares, which is factorable as a product of conjugates. So let's go to the right here. So we have x plus 6 times x plus 2 times x minus 2 equals 0. So we'll have 3 solutions here. X equals -6, or x equals -2, or x equals +2. And then we have to check these potential solutions with the restricted value of 0 or the excluded value. So potentially each of those could be solutions if we plug them in and check them. Number 4, solve the rational equation by first factoring the denominator where possible. It's our first step, because to determine the least common denominator, we need to have prime polynomials in the denominator. So let's first factor x squared minus 1, which is a difference of two squares. So we have 6 divided by the product of conjugates, x plus 1 times x minus 1. And there we can see that we cannot have -1 as a solution, because that would give division by 0, and +1 cannot be a solution because you'd have 1 minus 1. So we have 2 restrictions on x. And the last denominators are prime polynomials, cannot be factored. -3 over x plus 1. So the domain or potential or possible solutions is that x could be any real number except -1, +1. Another way to state this more briefly is just to write x cannot equal +1 or -1. Again, that could also be written, the domain is all real numbers potentially except curly brace, +1 or -1. So after you factor the denominator, which is necessary to do step B, which is to state the least common denominator, the least common denominator is the product of the prime polynomials of the denominators, which are x plus 1 times x minus 1. Right? You can get that from the first denominator, and then the others just repeat. Furthermore, if we put a 1 as the exponent on each of those binomials in the denominators, the greatest exponent on x plus 1 is a 1, so you would only use a 1 on x plus 1, and the same for x minus 1. The greatest exponent is a 1 in all the denominators. In more advanced problems, you could have greater exponents on those unique binomial denominators, and you would use the greatest exponent. Step C, multiply both sides and every term by the LCD. Let's see if we can squeeze that here. So we're going to go x plus 1, x minus 1 times 6 divided by the product of conjugates equals x plus 1, x minus 1 times 5 divided by x minus 1 minus x plus 1 times its conjugate times 3 divided by x plus 1. So the purpose of that step is so that we can divide and cancel these denominators. X minus 1 divided by itself is 1. X minus 1 will divide and cancel. X plus 1 will divide and cancel. So let's rewrite everything. We have 6 is equal to, and let's put the 5 on the left and then distribute the 5 times x plus 1. Then we'll put the 3 on the left so it's more familiar, times x minus 1. So 6 equals 5 times x plus 5, 3 times x plus 3. Simplify. So 6 equals 2x, and 5 plus 3 is 8. 6 subtract 8 will be -2 equals 2 times x. Divide both sides by +2. So x equals -1, but we have to check that against the excluded values, right? -1, +1 were excluded from the general set of all real numbers because -1 would give division by 0 on 2 of the fractions. So in this case, -1 is an extraneous solution. That is a solution that is a restriction. And so it cannot be a solution. It's an extraneous solution. And therefore, the original equation has no solution. So we state no solution. And the symbol for no solution, we can use the empty set, or we can use the null set. That's a circle with a / through it to mean no solution. Number 5, solve the rational equation And you want to note that the first two denominators, x minus 4, x minus 2, cannot be factored. They're prime, but the third denominator looks like a factorable trinomial with the greatest common factor of 1. So that's our first step. We're going to need to factor, if possible, denominators. So we have 5 divided by a prime polynomial, binomial, plus 3 divided by a not factorable polynomial. And then we have x squared minus x minus 2. And let's factor using factors of 8, 4 times 2. So we have the two binomials, first term x, and 4 times 2 is 8. Then we would figure out the signs, or to get a minus 6 and a plus 8, we need double minuses. And so multiply that out to check it. So the domain is generally all real numbers except any excluded values or restricted values. And that would include 4 and positive 2. So x cannot equal, solutions cannot be either positive 4 nor positive 2. Those are not possible as solutions. Again, this may also be expressed, the domain is the set of all real numbers except curly brace 2, 4. So after factoring, the least common denominator is the product of the unique prime polynomial denominator factors. That includes x minus 4 times x minus 2. Now, neither one is repeated because in the denominators, the exponents are understood to be ones. So the greatest exponent on any unique binomial is a 1. So therefore, you just include each binomial one time, and that is the LCD. So now the next step in C is to multiply every term by this LCD. Let's do that here. So we have 5 divided by x minus 4 times the LCD plus 3 divided by x minus 2 times the LCD equals x squared minus x minus 2 over the LCD divided by, and let's use parentheses here as well in the numerator, times the LCD. So next step is to divide and cancel. X minus 4 divided by x minus 4 is 1. X minus 2 divided by itself is 1. And then on the right side, both pairs of binomials divide and cancel out. So let's rewrite it. We have 5 times x minus 2 plus 3 times x minus 4 equals this quadratic expression. So let's multiply 5 times x, 5 times 2, 3 times x, 3 times 4 equals this quadratic. So 5 plus 3 is 8. Negative 10 minus 12 is negative 22 equals this quadratic. Now the quadratic term has a positive leading coefficient, so we want to keep a positive leading coefficient and therefore get, in this example, the left-hand side terms, bring them over by subtracting 8x and by adding 22. So we keep positive leading coefficient minus 9x plus 20 is equal to 0. Now, the greatest common factor of the trinomial terms is a 1. If we're going to use trial and error, you want to think of a pair of integer factors of 20 that will add or subtract to give you -9. So you would have 1 times 20, 2 times 10, 4 and 5, if they're both negatives, we'll have a product of positive 20 and a sum of -9. So that tells us to try factoring as the product of two binomials, first term x, -4, -5, and be sure to check that by multiplying. Looks like it will give us a -9x and a +20. So we have either x minus 4 equals 0 or x minus 5 equals 0. So potentially x is 4 if that's not a restriction, but it is, right? That's excluded value. That would make two denominators of 0, and thus those expressions would be undefined. So here would be an extraneous solution. 4 is an extraneous solution, or x equals 5, you could then check. So you would state the solution set contains 5, but 4 would not be in this solution set since it's an extraneous solution.